The assembly workspace is basically similar to the part workspace. The menu selections, toolbars, and Design Explorer reflect the tools and processes specific to the task of combining previously created parts into functional assemblies. In the assembly workspace, you gather up those parts you have created and group them into functional assemblies. The Design Explorer in the assembly workspace assists in the organization of exploded views of assemblies, as well as assembly constraints that help define the relationships of the parts in an assembly. Assemblies in Alibre design consist of any combination of native Alibre design parts and imported parts. New parts can also be created in the context of existing assemblies. To create an assembly, open a new assembly workspace. The Insert Part Assembly dialog appears. Here a part or an existing assembly can be selected and inserted into the new assembly workspace. All assembly parts are listed in the Design Explorer. To insert additional parts into the assembly, from the Insert menu, select Part Subassembly. Click on the screen wherever you wish to place additional copies of the part. Prior to applying assembly constraints, parts can be moved in the workspace by placing the cursor over the object, clicking and holding down the left mouse button, and dragging the part to its new location and releasing the mouse button. If you need additional copies, perform the same dragging procedure while holding down the Control key, and you'll create a duplicate part. Next, assembly constraints must be applied to properly position assembly parts with respect to each other. There are two ways to apply assembly constraints, though the end results are the same. The Quick Constraints mode will be used here. When using the Quick Constraints mode, the icons in a dialog box will vary depending on which items are selected. Mating surfaces on the end cap and lobe on the crankshaft are selected to line up the end cap. The first part selected moves to the second part selected. Now join the cap to the crankshaft. If more than two items are selected, the green check mark in the dialog box will disappear. Selecting that third item again will deselect it. Now constrain the crankshaft to the crankshaft journal on the engine block. The Quick Constraint mode automatically uses cylindrical align for this task. The end cap is still not fully constrained. The mating surfaces of the cap and block need to be constrained. The flip button will rotate that cap into the correct position. Now add an alignment constraint on the parallel faces of the cap and block for good measure. To apply assembly constraints, from the Insert menu, select Assembly Constraint, or right-click in the workspace and select Insert Assembly Constraint. To select the entities to constrain, left-click the edge or surface on one part, then left-click to select the appropriate edge or face on the second part. A mate constraint is applied to mating surfaces. The offset value in the dialog box is set to 0, so there will be no space between these surfaces, and the Apply button is clicked on. Now a cylindrical constraint with an offset of 0 is applied to the two cylindrical surfaces, and an alignment constraint is applied to these two surfaces. The other assembly constraint types listed in the dialog box include Orient, which is similar to Align but with no offset value, Angle, which will constrain two planar surfaces with a specified angle to each other, and Tangent, which will make either two cylindrical surfaces or a planar and a cylindrical surface tangent and constrained. Regardless of the kind of assembly constraint used during creation, the same familiar dialog box will show. All assembly constraints are listed in the Design Explorer and can be modified after insertion. Accurate simulation is possible when assembly constraints are utilized.